In this video, I'll talk about endpoint vulnerabilities. When we talk about endpoint devices, we're really talking about two categories of devices. We're talking about user devices like smartphones and laptops, but then at the same time, we're also talking about network infrastructure devices. Either way, depending on the type of solution we have, it might be hardware or it might be software, we need to make sure we apply firmware updates, or if it's software patches to fix any security issues. This would apply to network infrastructure devices like network switches, VPN appliances, load balancers, reverse proxies, network firewalls, Wi-Fi access point servers, and network printers. For example, if we're using wireless routers, it's important that we keep up to date with the latest firmware revisions in case they address security vulnerabilities. Endpoint devices, as mentioned, also include user-based appliances or smartphones or laptops and so on. So in the same way, we should make sure that we apply firmware updates and software patches to user-based endpoint devices. We should also limit the user's ability to change configurations and to install software, which includes drivers, as well as apps from mobile device app stores and whatnot. Now, we should limit that on all types of user-based endpoint devices like desktops, laptops, tablets, and smartphones. A demilitarized zone is a network segment where we place publicly visible servers that need to be visible that way. So that would include things potentially like public websites, but it could also include websites or FTP servers that are used only by employees. Now, a good argument could be made to say, well, those shouldn't really be publicly accessible if it's for employees that are working from home or traveling. Maybe instead, they should only be available after the employee establishes a VPN connection. And that's a good argument. So certainly we might place a VPN appliance within the demilitarized zone. Certainly we should also consider the placement of a reverse proxy that listens for connections to various servers hosted elsewhere. That is also another prime candidate for a DMZ or demilitarized zone. Strict firewall rules need to exist between the internet firewall and the DMZ itself. For example, if we've got a reverse proxy listening on port 80 for a web server elsewhere, then that firewall between the DMZ and the internet should allow inbound port 80 traffic destined specifically to the reverse proxy, since it's listening for that connection. Now, in the same way, we should have a second layer firewall with rules that controls traffic into and out of the DMZ and the internal network. So to continue our example with a reverse proxy listening on TCP port 80 for a web app, then maybe our second level firewall would allow port 80 traffic, at least that's the source port, destined for an internal web server port hosted elsewhere. We should also consider the use of varying firewall products. Now, why is that? Well, generally, using a variety of different types of products increases security, because if a malicious user were to compromise one type of router or firewall because they've exploited a known vulnerability, that same hack will not work on a different firewall product from a different vendor. Now, at the same time, it's a double-edged sword, isn't it? Because it increases administrative effort. Now you've got to track updates for firmware or perhaps software for different products. You've got different configurations, different troubleshooting techniques, and so on. We should consider the use of centralized radius authentication servers. So endpoint network infrastructure devices should never perform their own authentication. So we're really referring here to things like VPN appliances, wireless routers. They should not actually do the authentication. These devices are called radius clients. So a radius client isn't an end user on a smartphone trying to connect to Wi-Fi. That user would be called a supplicant. So the radius client in that example would be the wireless router. Now, the problem here, potentially, if things like wireless routers were to do actual authentication, if it were compromised, then it would reveal credentials. So instead, authentication should be forwarded from radius clients to a radius server. Radius clients will authenticate to the radius server using a shared secret that gets configured. So naturally, to harden that, we should be using a strong shared secret over an encrypted connection. Logging is crucial to track activity, especially after some kind of an intrusion. So therefore, we should configure log forwarding for endpoint network infrastructure devices so that the logs are sent elsewhere. So if the device is compromised, we still have a record of what occurred. Now, we might configure Windows event log subscriptions. Here in Server 2012 R2, I'm going to go ahead and click on my Start menu in the bottom left. I'm going to type Event, and then I'm going to start the Windows Event Viewer tool where log information is stored. Over on the left, I'm going to click on Subscriptions, where I will right-click on it and then choose Create Subscription. I'm going to call this Sub 1. Windows subscriptions that we're configuring as of right now are used for log forwarding, for centralized logging in Windows. What I'm going to do is leave this on collector initiated. This server will be the collector that will periodically reach out to other hosts on the network to collect log information. Of course, I could click the Select Computers button in order to specify those computers that I want to gather log info from. Down below, for events to collect, I would open the drop-down list and edit the events. And what I might do, for instance, is say I want to collect critical warning and error messages, specifically, let's say, from the Windows system log. And then after that, I would click OK. Now, what I must do in order for this to work is enable the WinRM or Windows Remote Management Service on target computers I want to collect log information from. Now, after I've done all of this machine will periodically, approximately every 15 minutes, poll the configured computers I will have selected so that the log information is stored here centrally. We can do the same kind of thing with Unix and Linux systems using the syslog daemon for log forwarding. The idea is that a compromised device and its logs are absolutely meaningless because they could have been changed or wiped by an attacker. So centralized logging to a host should be hardened, so the host itself should be hardened, and it should also exist on a secured internal network. For endpoint vulnerabilities, we should also have some kind of host intrusion detection and prevention system in place. Now, we might also do it at the network level. So a host intrusion detection and prevention system is designed to look at things that are specific to a host, like application logs. Also, it has the ability to decrypt information that arrives at the host. Network intrusion detection and prevention is designed to look at network traffic from multiple hosts, but depending on its configuration, it may not be able to look into the details of encrypted network traffic, like a host system could. And of course, it's always important to encrypt data transmissions and data at rest, both on internal networks and externally on the internet. In this video, we discussed endpoint vulnerabilities.